Welcome back to the YouTube video. Today we're going to talk about roots again, but this time on how to simplify them. In this page here, as you can tell, all these numbers, 0 plus 1, 3 minus 2, minus 10 plus 11, or minus 3 plus 4, all equals 1. But why don't we just write the 1 instead? Well, unfortunately, some teachers can be very, very picky, and they'll fail your test, even though your answer is technically correct. So, we know that square root of 16 equals 4, because that's the perfect square. But what about square root of 32? Well, square root of 32 is not the perfect square, so therefore it becomes an irrational number, which is 5.65685429, and the numbers just keep going on forever and it never repeats. But 16 times 2 equals 32. So how do we simplify the square root of 32? How do we do that? Well, we do like this. Square root of 32 would equal square root of 16 times square root of 2, or you could write that way as square root of 16 times 2. What about square root of 180? Well, that's an irrational number too. So we do like this. So we know that 2 times 2 times 3 times 3 times 5 equals 180. So to do that, we just square root them by putting the root sign over the 2 times 2 times 3 times 3 times 5. Or we could write it the other way as 2 times 3 times square root of 5. Square root of 5 cannot be simplified any further because it's a prime number. We could also do it the other way as square root of 2 times 2 times the square root of 3 times 3, and then times square root of 5. Or the simplest way to do that is to do just 6 root 5. 6 root 5 is exactly the same as 6 times square root of 5, because that's the, well, I can't remember the word for that, but 6 times square root of 5 is exactly the same as 6 root 5. So keep that in mind. Default. That's it. That's the word I was looking for. 6 root 5 is a default of 6 times square root of 5. So that's why we don't put the times in the middle. What about the square root of 72? Because that's an irrational number too, so we use that way. We do square root of 2 times 2 times 2 times 3 times 3. And also, I mark these two numbers, 2 times 2 and 3 times 3, because they are perfect squares. And we can just bring those numbers out and make it as a 3 times 2, like this, instead of writing 2 times 2 and 3 times 3 inside the square root. 2 in the middle cannot be simplified any further. So we also write it as 2 times 3 times the square root of 2. Or you could write it as 6 root 2. Remember, 6 root 2 is exactly the same as 6 times the square root of 2, like I mentioned in the previous page here. Like 6 times square root of 5 equals 6 root 5. So, you can simplify the roots in any kind of root, like square root, cube root, fourth root, and fifth root. But always remember to put the index number first, because if you don't put the index number in, it's always going to be the square root. Now, simplifying the cube roots. Now, in the cube root 72 is kind of the same as square root 72, but this one I highlighted 3 2's because 2 times 2 is a perfect cube. 3 times 3 cannot be simplified any further because it's a perfect square. And then we can take those numbers out and make it as cube root of 2 times 2 times 2 times cube root of 3 times 3. And it will also make it into as cube root 8 times cube root 9. That's the simplest way to write a cube root of 72. Now, simplifying root in fractions. So, 3 over square root of 2, we have to times the denominator with the same number, which is square root 2. So, numerator is 3, on the other side is square root 2 on the top, and if you do 3 square root 2 times the square root over square root, that's going to equal this 3 square root over square root of 2 times square root of 2, which will simply make as the answer 2 at the bottom. And this is the final answer because this fraction number is in fact an irrational number. 3 square root of 2 divided by 2 will equal 2.121320,344, and the numbers just keep going on forever and never repeats. So let's go through it one more time. Bear with me, guys. Not this one. So we've talked about simplifying. As I mentioned earlier, we could do this way with the adding numbers and make it into 1. We all know teachers can be very picky sometimes, and they could give you the failed test even though it's technically correct. We all know the square root of 16 equals 4 because that's the perfect square. And the square root of 32 is not a perfect square, but 16 times 2 equals what? Equals 32. So we simplify it like this. Square root of 32 equals square root of 16 times square root of 2. Also equals the square root of 16 times 2. We can also do it with the bigger numbers too. And you can simplify the root in any kind of root. Second root, cube root, fourth root, and fifth root. And simplifying the cube root, we just bring all the 3 2's together, and then times 3 times 3 cannot be simplified any further because that's the perfect square. And then we can make it as the cube root of 8 times the cube root of 9. And remember to always put the 3 as a index number if you want to do if you want to simplify the cube roots. And simplifying roots in fractions, we add the numerator and denominator and times them together. And the final answer will be 3 square root 2 divided by 2. But that's the final answer because that's a rational number. So we do not want that, so we have to keep it as like this. 3 root 2 over 2. And if you're very confused about this lesson, then I recommend you keep rewatching this video until you finally get to understand how the simplifying the root works. And also, you don't just learn by watching videos, you also have to practice too. So, I'm going to end the video right here. So, don't forget to like, subscribe, turn the notifications on. I have so much videos coming up for you very soon, so don't go anywhere. And I'll see you all in the next video. And also, I'm not just going to talk about math and space, I'm going to talk about lots of different stuff on this YouTube channel from now on. So, yeah, I'm going to stop there. So, yeah, like, subscribe, notifications on, and that's it. And I'll see you in the next video. Cheerio, have a wonderful evening.